Okay, we'll get started. Today I'm going to actually talk about the Shellshock attack. This was very new, okay, and about 2 years old, and it is a vulnerability in the bash, okay, and the bash is being widely used and in the lot of operating systems, okay. And on Piazza, some of students ask what is the difference between bash, dash, many other things, okay. So, and you probably heard a lot of these different kind of the shell program, right? There's a bash, we are familiar. Actually, in the VM, you're actually using dash, okay? So, and then there are the C shell and many other things. And in Windows, you have PowerShell, okay? They are all shell programs, right? And they're just different brand. They have different features, okay? So, and in our VM, the /bin shell, this one is not a real program, okay? If you look at the folder, this /bin shell is a symbolic link to actually the shell program. In the current setup, if you have not changed, it's actually just linked to the /bin dash. Okay, so if you want to link that to bash, and you can change the symbolic link. Okay, so it really doesn't matter much. Okay, some of the shell program may have some of the countermeasure. Okay, so for example, in the past, and when we work on the buffer overflow, and some of the shell they have a countermeasure built inside. So the attack doesn't work for the bash, but it work for the other one, okay? But that countermeasure later on was removed, okay? So it changed a lot, okay? So but they're just different shell, okay? This particular vulnerability is only relevant to the bash, okay? It's very specific to bash and not to the other, okay? But bash is actually probably the most popular shell out there. So this is related to the function for definition. Okay, so we know how to define variable. So this is how you can define a function. So in the shell, if you say I want to define a function called foo, and this is how you define that. So you put just like more like a C. Okay, so you have a foo and a parenthesis. Okay, and then you have this curly break, and inside of this, and you have your instruction. Okay, so we just the echo is printf more like, okay, and so after you define this, okay, and if you just try to see what function are defined, and you can use declare -f to see what functions are defined, and so in this case we only have one function defined, so it prints out the content of that function, okay. So if you now type foo, okay, which is just a function, and it's going to print out the inside function. So it's going to run the function, okay. So it's very, very straightforward to define a function, okay, and you can unset -f that function definition. If you declare it again, it's gone, okay, just like the variable, okay, but they have to follow particular syntax, okay. Now, if you want to pass your function definition to the child process, okay, so similarly, you have to export it, right? Just like in one variable, if I want to pass this shell variable, okay, this is in the shell. If you want to pass this shell variable to the child, you have to export this shell variable, okay. So similarly, if I define a function foo, okay, and if you look at this, okay, and I got this foo here running, okay, now if I say I export this function, I run another bash, okay, and that's going to create child shell, okay, and then whatever you exported, okay, will be actually if you look at this, right now I'm in the child, okay, and if you declare this again, you can see that foo function now is actually also in the child shell, okay. If you do not actually export it, okay, the child shell will not inherit this actually shell variable. This is actually the function, okay, not shell variable. Just very, very similar to the shell variable, okay. Now, that's another way to pass a function to the child. Okay, that's where the problem is. Okay, this one is fine. Okay, if you have a defined function, you pass this function to the child, nothing is wrong here. What is wrong is the second method that caused the problem. In this method, in the parents, you only define a variable, a shear variable, not a shear function. Okay, I'm only define a shear variable called foo. And you can see foo equal to a string. So inside of this string, it looks like a function declaration, right? I have parentheses, I have these things, but it's just string. When you say foo equal to this, and the bash doesn't care. Bash says, okay, you define a variable, inside of this variable, it's just this kind of random string, okay? So, and if you echo this variable, it's going to display this. If you're trying to declare minus f, saying you want to say whether you have a foo function defined, and you're going to find nothing. There's no function called foo. Okay, this is different from function declaration and variable declaration. Okay, so you define a variable. So that's why you don't see anything. If you say, do I have a foo function? You don't. You only have a foo variable. Now I want to export foo because it's a variable. When I export, that means I want to actually hand it over to my child process. Okay, and then I do the bash again. Okay, the child process start. If I echo foo, that's nothing. That shear variable disappeared. Okay, I just actually export this variable, right? But this variable disappeared, and this variable actually is converted into a function. Okay, so this variable now is converted. And if you declare minus f foo again, right, and you see the function declaration. So in the parent, you did not declare any function. You only declare a variable which has a function declaration inside the body of the string. Okay? But in the parents, it doesn't care. Right? You just have a string. So when the child is actually launched, bash is going to look at all this variable. It identifies whether there's a function declaration. Not function declaration, whether any variable has started with this. Okay, it looks for the starting of these two parentheses. It's trying to identify whether any variable carries a definition of function. If you find one, it's going to turn that variable into a function. Okay, that's what the bash decision. So this way, the parents can actually pass down a function to the child via variable. Okay, so this is what happened. Okay, so you can see that the child process now have this function. Okay, and if you type foo, and it print out hello world. Okay, so it's become the environment variable, becomes a function. So it's a parent and this child. And obviously, by doing that, so to achieve this, it needs to parse. Because when you define a variable, and it's very different from define a function, right? Define a variable, I only have a name and a value, right? That's all I need to know, right? Name and value pair. But when you say I define a function, I need to parse the function. It's a code. The function is a code. It's not just the data there. So when the bash actually find out that's actually the parenthesis at the beginning, it says, oh, this is a function. The content of this variable is function. Let me parse this string. Let me parse this string. Turn that into function. Okay? So it's kind of, it has to compile the code. Okay? So this is where the problem happens. Okay? So I just want to make sure you understand the process. Okay? Any question about this? Okay, good. Now the vulnerability is here. So if inside of this, okay, this is inside of this variable declaration, and you actually, this is the end of the function definition. But after that, you attach an additional command, and you say echo extra. So kind of you have a function declaration and another command, right? So this is the content of foo. Now it goes to the bash, the child, and right at here, right at the beginning of the child process, this actually got printed out, right? So, and this is exactly the result of this command. So that means this command get executed right here. We didn't do anything, right? We just set our environment, set a shell variable in the parent shell, and then say I'm going to create a child shell and run bash, and immediately this get executed. So what do you think happens? Where did this get executed?
During the conversion process when it's...
Exactly. So remember, when the child process gets started, it has to look at all this shell variable, right? Identify the one which looks like this, and only look at the beginning. And then it said, I'll find a function, and it will parse here. It will parse here. Okay? And if you just parse that, right, you compile the code, that's okay. But somehow, and the programmer made a mistake. Okay? It used a function which not only parse this, but also execute the command. Okay? So it's trying to reuse the actual a function, but not knowing that function can do more. Okay? That was a mistake. Okay? So you can see this command get executed. So let's look at how did this happen. This is actually source code. We actually look into the bash source code, and so we actually removed a lot of things. So here, one thing they did is they will make sure that actually if the environment is actually privilege mode, it will not actually pass the function. So they don't want the parents and to pass a function to the privileged child. If the child is SetUID program, the parents is not, and it will not pass that function to the child. Why? Why do they do this? If I'm in the parent's process, I create a child process, and here, whether to pass the function from the parent process or not, depending on whether the child process is a privilege mode or not. SetUID is a privilege mode. How come? Why not just pass that?
So it will execute the same way it just executed the
No, the program doesn't even know the vulnerability, okay? The program doesn't know that vulnerability. That was later on found out. So, but the program did actually make a decision not to actually allow the parent to pass the function to the child.
Same reason you would stop an unprivileged, for me, it'll pass a lot of other stuff. You don't want to say, allow them to overload a function maybe that's designed in privilege mode, something that would allow you to escalate privileges.
Okay, yeah, that's very good. So you remember what makes the SetUID program secure? What makes SetUID, so normal user can run the SetUID program. What makes them secure?
The functionality is defined.
The function is defined, and they don't run your code, right? They only run whatever is the code inside the SetUID program. They don't run untrusted user's code, right? So that's what makes it secure. Now, if you allow me to pass a function to you, right? And what if I can overload your function, right? Or what if you accidentally call that function and you're calling my code, right? So this is definitely a good decision, not to actually allow the function to be passed down to the child if the child is a privilege. Okay, so that I would have a sum up for this decision. Okay. Okay, so it did that, and so it identified this pattern. Okay, so basically, and make sure the privilege mode is not true, it's 0. Okay, it's not a privilege, and then identify that pattern. When that pattern is identified, what it does is, so this is the function, this is the variable definition. Okay, so there's something here. Yeah. This is actually the function. This is the variable definition, right? Full equal to this one. So what this actually the code does is just simply replace that with a space. Okay, and now this become a function declaration, right? It used to be just the variable definition, full equal to this, and by replace this with a space, become function definition, right? So, and then the program says, okay, I will just pass this to my the parse and the execute function, because I get a string which is a function definition, right? And then I'm just going to pass down this to this function, which I already have. Every time you type something here, you type something like this in the command line, I have to do the same thing. So I have that function already, right? So I'm going to pass that. But it doesn't check there's another command attached. So the parse and execute basically is going to pass a shell script. This is a shell script, basically. It says, oh, okay, you gave me a shell script. I'm just going to pass it. I'm going to run it. Okay? So there's nothing wrong with here, but what is wrong is you're not supposed to pass this as a shell script. Okay? And because you may have a command after function definition. Okay? So that's actually the problems. Okay? So with actually the bash. Now, can we exploit that using the setuid program? So if I know that if I have a setuid program which runs a bash, right? Okay. So assuming all the other environment variable things, okay, that we talked about, this path, all those other things have been taken care of, right? Now, can I use this? Can I, in my normal user, define something like that? And then I'm going to call bash. Not call bash, call the setuid program, which runs bash. Okay? If the setuid doesn't run a bash, it doesn't matter. Okay? If the setuid program is a shell script, assuming, and it will run a bash, right? Can I exploit that?
Yeah, it's like creating how we create the ls. We can just pass a function by name ls and it will be executed.
But there's
No, if you run the ls, you are not going to run a function. Okay. Okay.
It shouldn't, because you have the thing to check to see if you're going in.
Yeah, you just forgot about this here. so remember, if it's a setuid program, it will not allow you to do that. Okay, because I'm not a normal user, and that's why it doesn't allow. Because otherwise, all the shell script. Actually, what you said is right. If I'm in the shell script, I have ls, and the shell script may consider this as function, right? If I define a function called ls, and in your shell script you run the ls, and that could be interpreted as a function ls, okay? And depending on which one take the preference, right? Probably function take the preference, and then the command, right? So what you said is right, yeah. So if we don't have this, you can see I can't use this setuid to run the shell program. I mean, using the setuid program to run the shell script itself is dangerous. Okay, so you should never do that. Okay, so but if somebody did that, and that can be easily exploited. Okay, so not because of there's a problem in the shell script. It's simply because of the function that you define here can affect the command inside the shell script using the function. So that's why you should never actually allow the normal user to inject their code into a privileged program. That is very, very dangerous. Okay, so that's the main reason for this. So now if this doesn't work, so why is this dangerous, right? Yes, this can run command, but you can run command with your own privilege, right? There's no danger at all, right? So the danger is not with the setuid program. In our lab, we have one task ask you to work on the setuid program. In a particular condition, that still works, but that condition is not common. Okay, so we just let you get an experience with that. The real danger is not setuid program; it is the CGI program. Okay, so that's what we're going to focus on. So basically, in order to trigger this, you need to be able to execute a bash shell. Okay, it has to be a bash. Okay, and you need to actually trigger the environment parsing logic. Okay, if it only run this bash, you trigger bash, but there's no function definition passing down to the bash, and it doesn't matter. Okay, so we need the two conditions here. So once we got let the bash run, second, and we need to pass our environment variable, not share variable, sorry, pass a share variable into this one, okay? And I should say the pass a variable, okay? Because in the example I'm going to show you, it's not a share variable. It is actually an environment variable passing, okay? So it pass a variable and to the to the child process, okay? The child process run bash, okay? So what I need is if I can pass an environment variable to the child process, and the child process run bash. We need something like that. Okay. So remember, if I pass the environment variable to the child process, what would the bash do to the environment variable?
Parse it.
It's going to parse that, turn that into share variable, right? Okay. So it will take the environment variable, become the share variable. Okay. So in the case in the example that we'll show, it is passing the environment variable. It's not from a shell to shell. My previous example I show you from the parent's shell, a child is a shell. But in the example I'm going to show you, parent is not a shell. Okay. So, but as long as the bash turn that into a shell variable, it look for the function definition. Okay. When it find the function definition, it will parse and execute. Okay. So this is related to how the CGI works. So the CGI satisfies that requirement. Okay. So let me just show you the CGI, the process. So not many of you are familiar with this. So initially you start with HTTP request. Okay. So and usually we have a web server. Apache is a popular one, web server. Now, Apache Web Server, if you're looking for a static content, okay, a page, and the Apache Web Server is going to load that from the disk, find the HTML file, and load it and return back to you. That's for static content. Okay, but these days, a lot of content are not static. They are actually the dynamic. So there are PHP, right? You probably use PHP. That's dynamic. Okay, CGI. That's a dynamic. So you are requesting a dynamic page. Okay, the end with .php.cgi. Apache know that. Apache says, oh, you're asking for the PHP. Let me send you to the PHP engine. Okay, so what? And if you are asking for CGI, it's going to use a standard CGI interface to invoke an external program. Okay, so what it does is going to say, I don't understand the PHP. I'm Apache. I don't understand that. I don't understand your CGI. Your CGI could be a C program, binary, could be the shell script. Okay, I don't understand that, but I'm going to fork a process. I'm going to fork a child process. Okay, then depending on the type, if your PHP inside this child process, okay, this is not a child process. I'm going to run your engine. Okay, I'm going to execute. So if the PHP, I'm going to run a PHP engine. Okay, and I'm going to give this to the PHP engine. Okay, then PHP engine is going to actually run that and send me the result. Okay, if it's CGI, okay, and then it should just execute that. So it's going to child process is going to do the exec v. Okay, and that exactly, so many CGI program can be binary, can be other type of script, and here a lot of CGI program they start with /bin bash. So they are beginning. It's a shell script, bash script. Okay, so CGI shell script is easiest to write a shell script. Okay, to write a CGI program. So it will just basically execute exactly of this one, and that's going to trigger the bash. Okay, so this is where the bash is going to be triggered, because the first line is basically says this is a bash script. Okay, and so this one will be executed. The bash is going to get executed. Okay? Now, this is the execute, but that's one important thing. The important thing is Apache server need to send you some information to your CGI program. It need to give you, so this is the process, new process. Apache said, I have a lot of information I need to give to you. For example, I need to let you know the browser information, right? And what type of browser, right? When the browser sends a request, it sends you a lot of information to Apache. Okay? Some of the information will be passed down to the child process, so you can process the request accordingly. So how can they send from this process to another process? How do they send data from one process to another? How? What is the easiest way for you to pass down some data from one process to the other?
Variables.
Environment variable, okay? So Apache says, since I'm creating the process. If these two processes are already created, they have no parent and child relationship, and you cannot do this. Okay, you have to use IPC mechanism to send this. But since I am creating this process, right? Remember, when I create a process, I do the fork, right? And then I do the exec v, right? The third argument allow me to send me a sequence of data to you as an environment variable. That's the main purpose of environment variable. Okay, so that's what Apache does. It actually sends the information, some information from the browser, okay, from the client side, and send that to this child process as environment variable. So now what's the attack surface here? Now you understand this is how it works. Where's the attack surface? Where's that? Do you see a risky surface there?
The client can send you whatever it wants as far as those variables.
Very good. Now your CGI program now is taking the data from the client. Okay, so this is also the data. Okay, so this environment variable cannot be trusted. Okay, so this is definitely attack surface. Of course, CGI also take the normal data from the client, right? The client sends a request. In the request, it contains the data. That data usually is also goes into the CGI program. That is obvious. You know that input. You know that it's untrusted. So you know how to deal with that. But this is a hidden input you don't know. Okay? CGI program doesn't even know this data get into their memory. Okay? And with a bash vulnerability, it's going to actually affect the result. Okay. So this is actually the data. So let's take a look at what kind of data is passed down to the CGI program. To see that, I just write a very simple CGI program. Okay. So this is a very simple CGI program, only 4 lines of code. What I do is I just print out all the environment variable. Okay. This is a shell script. Okay. And so the first 2 lines is important, okay? Because the result that you generate, this is a CGI program. The result you generate does not give back to the user directly, okay? You give back to Apache server. Apache server and turn that into a web page, and it give back to the browser, and the browser can display that, okay? So and you need to specify the type of your data. So you said my type is text/plan, okay, and leave a space in there, okay, leave an empty line in there, okay, and if you don't specify that, and the browser may not be able to get the right result back, okay. So this is just the protocol, okay. So a lot of students made a mistake when they actually do the Shellshock attack. They forgot these 2 lines, okay. So I just echo environment variable, and I string, okay, and the current environment variable. And I send a request. If you look at, I'm running the server on the same machine, okay, local host, and I put a CGI in the folder, and Shrita is going to tell you where that folder is. It's also in the lab description, okay. And when I send the request to here, you can see it prints out a lot of environment variable in the CGI process. This is the current process of CGI, okay. And now you can see anything started with HTTP. That very likely is actually it's not actually the environment variable of that process. So that process gets this environment variable from Apache, right? Normal process, they usually don't have environment variable like that, right? If you run a shell script, how come you will get environment variable started with HTTP? This is because Apache create a set of environment variable for this child process. Where does it get data? Now, if you just look at a few, the HTTP host, that's local host. Okay, so here it's related to the URL. HTTP user agent, where's the user agent? This is on my browser. I'm actually doing the sniffing on my browser to see what goes out. Okay, so when I type this, I'm actually monitoring, and this is called live HTTP header, and we're going to use that actually in our web security labs. And I'm just capture what goes out, and you can see this one goes out. Okay, this is from my browser, and this is what executed on the server, and the result comes back to me. Okay, and you can see the host actually is the same as here. The agent, I have a user agent in Mozilla. I'm using Firefox browser. Okay, so this is generated by my browser, and then this one turns into this environment variable. Okay, and I have this the other things. So basically, this is sent from my browser. Okay, so my browser have this data, and then the server, the Apache server, is going to turn some of the data that I send to the Apache. This is in the HTTP header. This is a request. I'm sending a request, and all of this is header part. Okay, so it turns some information from the header into environment variable. Okay, and then this header environment variable is going to pass down to the child process. Okay, and so you can see it's passed on the child process, and so it doesn't matter whether the child process is bash or not. It doesn't matter. Okay, it's create a child process Apache server. Okay, and then all the environment variable will be there. Okay, so now user can actually control what goes into the environment of the server. Okay, so usually this is not a big deal, right? Because CGI program is going to accept the input from user anyway, right? That's data from user, right? So yes, you can set some environment variable. Now let's look at what I can send you. So I'm going to actually use that the agent part, the agent field. Okay, I'm going to put my information there. I know this information will go to your CGI program, the memory. Okay, and I know your bash is going to parse that. Okay, so instead of using the browser, you can do the attack using the browser. But usually when we do the attack, we like command line. Okay, so curl is a command line, the tool, okay, and that allows you to send out HTTP requests, allows you to set different part of the header, the HTTP header. Okay, so it's very, very useful, the tool, which we're going to use very frequently when we do the web security labs. Okay, so now this part, everything here, so this part, so when the curl basically you will have a URL somewhere, okay, curl URL, and that will generate a HTTP request to that URL, okay, and if you say -a, okay, and you can specify basically a string for the -a. -a is to set the agent field, okay. So let's go back to the previous one. So this field, user agent field, that in the browser set it for you. Browser is going to actually look at which browser you are using, right? It's going to set this field automatically for you. Okay? And curl allows you from the command line to set that field. And that's why we like the tool, because we can actually do whatever we want. With the browser, you have to stick with what the browser can do. Yeah, you can change that, but it's very inconvenient. Okay? So in our case, we just use a curl to use -a to set the user agent field. and that user agent field is going to convert into that HTTP environment variable. Okay, so now you can see this is what I do. Okay, I'm just curve minus a. I just use the CGI. I know my CGI is running a shell script, bash. So you can see this one, this whole command, okay, is quite long here, up to here. It's passed down as the user agent, and then becomes the environment variable. Okay, and then environment variable is going to be parsed by bash, and the bash is going to create a function here, okay, for this one, but it's also going to execute whatever I put beyond the function definition. So it's going to actually echo, print out this content. As I said, you need that, otherwise your Apache doesn't recognize that. And then you need an empty space, empty line, okay. And then you run your command. This is the way you can run your command. Okay, so I run /bin ls -l, and you can see what I get back. I get back the outcome of ls -l, and this is the outcome of the command on the server. Okay, not on my computer. Okay, I'm just getting the ls -l executed on the server machine. I get the result. Okay, and this one actually lists the directory of the I think it's the folder of the CGI program with the CGI. So you can see I have a CGI in there. Okay. So this program is a benign, right? There's nothing. Yes, you get a program to run, but there's no damage. You only see that. So I also run another. So I try another one. I just want to see. I want to steal something from the service, right? The content that is not interesting. I want to steal something. So I was looking for where could be the secret, right? Can I steal the /gcc shadow file? Can I? Can I do that?
No.
Why?
Normally they don't run it through privilege.
Yes. So the CGI program, okay, this is the improvement, okay. Many years ago, the server runs, the Apache server runs with root privilege, okay. That was very dangerous, okay. And later on, they removed that, and they let actually Apache server, the web server, to run with a special user account. So in some of the systems, there's a special account called nobody, okay. So if you see an account username called nobody, don't be surprised. That just means that a user account called nobody, and nobody actually log into that account. It's only used for the web server to run. It's a user ID, right? And you can call it any name you want, right? In our VM, I think it's called WW. It's called WW or something, right? That user is called something. Yeah. Is that? Okay, yeah. So Apache is running with that actual user account. So this way, even if Apache is compromised, and what actually the attacker can gain is the privilege of that user. Okay, so that's limited the power of the attack. In the past, that was a really bad decision to run with root. Okay, so you cannot steal actually the shadow file, because shadow file is protected by the root account. Okay, and if you run with this normal user, you don't get that. So I was looking for something else. So, and I know this inside of the web server. So when we get to actually the web security, and especially when you use if you have back end actually the application, and if they need to actually log into the database server, okay, the password has to be inside the code. Okay, although we don't like that. Okay, we shouldn't put any password in the code, but for that case, there was no other choice. Okay, well, we will talk about that. So all this PHP code has to put that password of the database login. So in this case, we log in with root and log in with seed Ubuntu password, and that is stored in a file, okay, or stored in a program, and they have to do that. So if you know that, and you can just go after those files. Okay, those files, they are usually at the word readable and on the machines. Okay, so, and I was basically cat that program. I know there's a file in one of the web folder, and I was able to actually get this credential. Okay, they do have a limited, so this attack do have a limit. Those database servers, they usually will not allow you to log in from outside, only allow you from logging in from inside. But that's okay. Once you get this password, right, you already get your program running inside, right? You can just use that password and do further attack. So it just once you can get the program running in the door, right? If you get this credential, and you can do a lot of damage. Okay, so this is some of the command you can try. Okay, so to get a warm up, what we really want is not something like that. We want to be able to run arbitrary command on the server, okay, using this vulnerability. Okay, not just one command. We would like to be able to run a shell. Okay, remember, the best things the attacker want to do is to be able to run a shell on your machine or with your privilege, right? That's actually the crown jewelry of the attack. Okay. So that's what we are going to talk about more. Okay. So how do we actually get a shell? So attacker is here, and this is a server. Now using the actual Shellshock attack, if you remove all this fancy part, what really allows the attacker to do is to run a command on the server. That's what enables the attacker to do. Through the Shellshock vulnerability, now attacker can run a command. Any command, okay, because it's shell. So any command, as long as it's in there, and you can run. Okay, so you're allowed to run one command. Okay, and so the idea is if I can run the /bin bash, okay, just run a shell, and that will be best. If I get a shell prompt, right, I can just keep typing whatever the command I want, right? So what if we just run the shell? So instead of running /bin ls -l, what if I just run /bin bash? Can I do that? Right? You said to run a command, I just run /bin bash.
But it won't be useful for that attacker since
Why?
he won't get an interactive shell for himself to execute more commands.
Very good. So you can run a shell. Shell will run. But you have no control. The shell is going to run on the server. Okay? On the server, okay, and you are here, and you cannot type into here. And whatever the result you get, you won't be able to see that. Okay? Because when the shell is running, it's running inside it's using any program that runs, they have standard input, standard output, right? So standard input usually is your keyboard. So if you can access the keyboard on the server, yes, you can type things in the bash, right? If you have access to that small monitor, right, on the server side, yes, you can see the outcome of that. But remember, you are not on that. Okay, you are here. Okay, so this is actually a very common technique. Okay, so attacker want to run this, they want to control the shell. Okay, so the technique is called reverse shell. So this is not like running a shell on your own machine. Okay, and you automatically get access to your input device, output device. I'm running here, but this control has become here. That's called a reverse. Okay, so when some of students took my internet security class in the TCP/IP attack, and we do use that actually the techniques to basically send things over the network and to run a reverse shell. But here we're going to use that again, similarly. Okay, so the idea of the reverse shell is actually quite complicated, but once you understand that, and it's not that complicated. What enables you to control this? Okay, when this program runs, it's a process running, and this process have 3 default devices. Okay, and STD in, STD out, and STD error. Right? These are the 3 standard devices attached to all this process. Okay, and STD in the file descriptor is 0, 1, 2. So in your program, okay, if you actually write anything to this standard input 1, that's going to be displayed in your monitor, in your terminal. If you read something from 0, and you're actually reading from the cable, okay. So, but those are the three the device that are attached to all the processes. Okay. So if you type in the terminal, you type a command, and the terminal and the terminal is actually the standard input output arrow, and it's going to be inherited by the child process. Okay. So that's why whatever you type is going to show up on the terminal. But here, this is going to be the local. Okay. Now, in order for you to be able to see that, you need to redirect that. You need to redirect these three devices, okay, to our remote machine, okay, not to another device on here, but through a TCP connection back to the remote machine, okay. So that's what we're going to look at how to do that. It's quite tricky. So I'm going to just show you the demo, okay, show you, but I will not show you the command we inject, okay, because I want to leave that as your homework, okay, because that's what you need to do for the lab. I'm only going to emulate. I'm going to only type command here. Directly, I'm going to type the command on the server. I'm going to create a reverse shell back to another machine, okay. So I do not inject the code directly. So your job is to learn from what I do here, and then somehow inject using the shell script, the Shellshock attack to inject what I did into the server. Right now, I'm just directly type on the server. I have access on the server. Okay. In your attack, you don't. Okay. So I have these two machines. Okay, and and this machine. So I'm on the attacker machine. Okay, and this is the victim machine. This server machine. Okay. So in the attack, you would actually do the Shellshock attack from this machine to here, right? And that's going to actually lead to a command get executed here, right? So this machine is going to run the command and send it back to you. So I'm going to write the command right now here. So if I just do the /bin bash, right? Nothing happened, right? Nothing happened to the server because I'm inside the shell, so I have a control if I have access here, right? Useless to me. So now I want this to call back. I want this bash to call back the attacker machine. So for that, I need to set up the server listening to the callback. Okay. So I'm going to set up the TCP server and using the netcat command. Okay. So I'm going to listen to the port 9090. Okay. So now I'm waiting for this to call back. Okay. So now I'm going to type this. So I want the outcome. That's first. I want the output of this command to go back to my attacker machine. Okay. So to do that, I need to redirect output, right? So we know how to redirect, right? Redirect. So if we want to redirect to a file, we know how to do that. But how do I redirect this to another machine? Okay. So the good thing is you can just use in a special file called /dev TCP, and so IP address and port number. Okay, it's a virtual file. Whatever you actually redirect to this virtual file, and the OS knows you want to send this over the TCP connection to this machine's this IP this port number. Okay, and the system knows this is not a real file. There's no such real file here. It's a virtual file. So if you type this, and you can see I got a connection from 2.5, right? I immediately got this connection, and now whatever I typed in here, right, should go to here, right? So let's see. Right now I still have a control. I still have to type here because the input is still on here, right? If I type this, and you can see whatever I type here is going to redirect it here, right? So you just look at my mouse. My mouse is in here. I didn't touch in here. So I'm just type ls-l again, pwd cls clear. Okay. So you can see I don't get anything back from here because all my the output device get actually out to there, right? First thing, but my share prompt is still here. I still get share prompt in here. How come? I already redirect the outcome, the input, the output. Sorry, but this share prompt is also printed out, right, by the shell program. It's not magic. The shell prompt is printed out by the batch program. How come I still get it here? Take a guess.
We haven't redirected the inputs.
No, this has nothing to do with input, right? This is the printout. Printout is the output.
Oh, okay. So
Uses a different device.
Yes, use a different right. That's a very good guess. So it turns out the shell prompt is printed out to the device 2. Okay, so you have to redirect device 2, and for the shell prompt to come up here. Okay, so right now you can see it only shows result, but the shell prompt is still displayed in here. Okay, so let me just redirect that. Let me redirect this. Okay. So the 2 is so if I want to redirect my device 2 to device 1, okay, because I know now device 1 is that TCP connection, so I'm going to redirect 2 also to 1. So both 2 and 1 now they're the same, okay. So I'm going to do this now, okay. Do this one. So let me exit from this batch first. Okay, so I'm exiting from here. Okay, so now I'm going to do this 2 redirect. So we are directing a file descriptor. So that's why there's this end sign here. Okay, so if you don't do that, that 1 becomes a file name. Okay, and this means I want to redirect 2 to the file descriptor 1. Okay, file descriptor 1 now point to this TCP connection now because it's already redirected. So. Oh, yes, thank you. I'm going to read. So my server just finished because I exited from there. So I'm going to do it again. Okay, so now I'm going to. Okay, now I don't see anything here, right? So if I type ls, I'm still type ls minus l. Okay. So where's my prompt? Okay, I forgot minus I. Yes. I need to make this interactive. So I forgot about this one. Okay, so it should be minus I. Otherwise, I don't get a prompt. Okay, now you see I got a prompt here, right? Now, so I'm still on here, right? Now I don't see here. I type look at my mouse here. I am typing here right now. I'm typing L, S, and you won't see anything here. You're going to see here. Because whatever I type is actually to be echoed back to device 2. Okay, so I type L, right? You see here, right? But my mouse is here, really here. I'm not cheating, right? So minus L. So and everything's here, but I still have to type in here. I can't type here. If I do type here, I can type, but nothing happens. So whatever I type, I still fit into this terminal. I didn't go to the server, right? I need to do one more thing. So now tell me what should I do? Okay, so let's run this. Okay, now tell me. Okay, what should I do?
We should redirect the output.
Yes, type the command. Now you tell me what command should I type?
1.
1.
Lesser than and.
Less than.
And 1.
And 2.
Ampersand 1.
Okay, so.
Shouldn't that be 0 though?
Okay.
Because 1 is your.
Oh, yeah.
Right? So that's just for this 1. Okay? I think 2 should be the same. Yeah. So here I'm redirect input 0 also to 1. Okay, that means I'm taking the input from that actually TCP connection. Okay, this 1 now is represent the TCP connection. Okay, so I'm actually taking the input from that TCP connection. This NC command allows you to type. Whatever you type is fit into the TCP connection. Whatever comes from the TCP connection is printed out. So this NC is called a netcat. Basically just doing this echo back things. Okay, so let's do this. Try to see whether it works or not. Okay, now I get here, right? Now if I still type on this blue machine, nothing happens, right? Because my input now is redirect to here. Now if I type here, right, it works, right? So to make sure I'm not cheating, so I just want to see what I'm typing in the server machine, right? From the prompt you can see, right? But you may see that prompt is cheating. So let's just run the command if config to see the IP address. So that will not cheat. And you can see the IP address 2.5, and that's this machine. Okay, I am on the 2.7. This machine is 2.7. And you can see by doing that, I get a reverse shell back. I am now control this shell now. That shell is running on the server machine. Okay, and this is a very, very powerful tool. Okay, and for the a lot of attack, we use that for the TCP. And Shrita just came up with the idea, and to also try the reverse shell for the buffer overflow. Right now, our buffer overflow using setuid program. So he's trying to turn that into a server program, and so you can inject the code to the server and somehow do a reverse shell. So he's going to tell us whether he can succeed or not. That's going to be very challenging. But the reverse shell is a very important skill for the attacker when they do, because when most of their attack, they actually attack from remotely. Okay, so they are unlike our setuid program, we attack locally, attack a privileged program. When you are remotely, anything that's run on the remote server is a privileged program to you, right? Because you have no access to them. But if you can somehow inject some command to the remote server, okay, and you will be able to control this server by using whatever the privilege that is provided. Okay, so by doing that, and you can see we can actually inject the reverse shell command. So command is very simple, just like this. Okay, just don't forget about the -i. Okay, but you should not do this. Okay, I'm just sitting in front of the server machine. You should not. You have to sit in the remote machine using the Shellshock to inject the command and to the server, but get the same result. Okay, so if you do everything right, and you should be able to here by running the curl. All you need is run the curl, right? You run the curl, you put whatever we put in here, right? Send to the server, and you're going to get shell prompt back, and you have the control of the server. Okay, so any question about that? So that's pretty much, okay, I'm done with slide now. Yeah, that's pretty much what a Shellshock is. So it's very, very severe, the attack. But you can see the mistake is very small, right? It's very small. It takes them probably just a few minutes to fix that problem. But that problem has been there for many years, okay? So that means a lot of machines are affected. You can update the machine. Our VM, the bash version in our VM is vulnerable. Okay, we intended not to update that. Otherwise, you won't be able to do this lab. Okay, but the bash is updated. So if you are running a new machine, make sure that bash is updated. But CGI program, they are very common in web server. Okay, so we are not talking about a web server like department web server. A lot of small device, they have a server, right? Maybe you see that, right? Router, right? Your router have the web server inside, right? And very likely they have a CGI inside, okay? Because they have to run code, right? They don't just serve the static page. When you get to the router, what they do is they're going to actually run something to get some status for you, right? So very likely they have raw CGI. Those routers cannot be updated. Okay, you bought it, and it's vulnerable. Okay, so that's how severe the problem is. And so basically, I mean, if your router get exposed to the outside, if you do run bash, your router do run bash, and chances are, and people can actually hijack your router. Okay, so if that's the case, throw them away. Okay, buy a new one. So yeah, no, new one may not guarantee to actually fix the problem.